All right, so we're looking at the review for your next test right now. And here's the first problem in the review. It's analyzing a graph. Use the graph below of f of x is 1.5 times the absolute value of x minus 3, and this will be our v. And g of x is 2 cubic roots, blah, 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 and this will be our kind of sideways s. Answer parts A through D. For what values of x does f of x equal g of x? So the x values here where we have equality are at 0 and 4.511. That's where we cross paths, those two values of x. So I'll type that out so you can see it, but we're looking at x equals 0 and x equals 4.511. Pretty simple. Part B is where is g of x, which is the blue line here, our blue curve, less than v of x, which is the v. So I'm going to highlight the paths. Along this path, the blue line is below the absolute value, and also here. And I'm going to define them, and they want intervals. All right? So I'll write the inequalities first. It looks like when x is less than 0, which has an interval of negative infinity to 0, and when x is bigger than this 4.511, which has an interval of 4.511 to infinity. All right, what do we got up next? F of x is less than or equal to g of x. So if things have changed and there's equality, f of x is less than or equal to. F of x is the v, and it's going to be this path right here. This path happens for x values between 0 and 4.511. So let me write down the inequality first, and then we'll translate that inequality into interval form. The inequality would be 0 less than or equal to x less than or equal to 4.511, which has an interval form of 0, 4.511. Pretty simple. All right. Next up, we have f of x being greater than or equal to g of x. The two paths where that is true are the tops of the v. Again, f of x is the v, so there and there. Let's write out our inequalities and we'll convert them to intervals. The ultimate goal here is intervals, but inequalities are supposed to be what you know first. There's a greater than or equal to symbol there. It happens when the x value is less than or equal to 0. And when the x value is greater than or equal to 4.511. Now, how do we write that as an interval? Well, less than or equal to 0 is going to be negative infinity to 0 with a bracket. And the word and is unioned with the other side here, 4.511. And it's going to move to the right forever, all the way to infinity. So, there's the first question of the review sheet. It's actually 4 questions. 2, we have equation writing. So there's a lot of stuff on here. I'm highlighting these places right here. Those are called turning points. There are 3 turning points. So what I know from that is the polynomial is at least the number of turning points plus 1. So there's 3 turning points. This is a 4th degree polynomial. That's what I know. All right, some other stuff here. Where are my zeros? I have zeros at x equals -2 right there. And if you look at it, it's crossing. So the multiplicity is 1. I have another 0 at 0, also a crossing. Multiplicity is 1. I have another 0 here at 1. It is a touch, which means its multiplicity is 2. And I have another 0 at 3 right here, and it's crossing. So its multiplicity is 1. All right, now let's take these things and convert them. Every single polynomial has the letter A in it. It's the first letter of the alphabet. I have a 0 at x equals -2. The factor is x plus 2. Its multiplicity is 1, so the exponent is to the first power. I have a 0 at 0, so the factor is just x. I should probably write these down off to the side up here. Highlight this text, shrink it so I can add to it. For some of y'all, this won't make much sense. I'll try and dumb it down as much as I can. So the factor is x plus 2 to the first power. Here the factor is x minus 0, which becomes, by the way, to the first power. Multiplicity was 1, which just becomes x. X equals 1 has a factor of x minus 1. Since the multiplicity is 2, it's raised to the second power. And x equals 3 would be the factor of, you see how hard this is? You just change signs and you're done. X minus 3, since the multiplicity is 1, the exponent is 1. Anyways, back down here. Where was I? I just talked about the x, so now I'm moving on to x minus 1. It's going to be to the second power. And the last factor is x minus 3. And you'll notice if you add your exponents here, there's a 1 here, plus 2 makes 3, plus 1 makes 4, plus another 1 makes 5. X to the fifth. By the way, the wording up here was at least. Oh, because I can't count either. There's 4 turning points. There we go. Forgive me, it's Monday morning. 1, 2, 3, 4 turning points. Fifth degree polynomial. All right. Now I'm supposed to figure out A. I'm pretty sure you're supposed to figure out A. All right, you see up top where it says that the point 2, -8 exists on the graph. So since 2, -8 exists on the graph, I know x equals 2 when y equals -8. I can plug that stuff in. -8 equal to a times 2 plus 2, because x is 2 times 2 times 2 minus 2 squared. That's not 2. I'm making all sorts of mistakes here, aren't I? 1. I don't know why I wrote down x minus 2. And then 2 minus 3. Probably because it's Monday. This little guy is supposed to be squared. Do some evaluation. -8 equals a 2 times 2 is 4 times a 2 times a 1, even a 1 squared is still 1, times a -1. This will give me -8 equals a times a -8, because 4 times 2 times 1 times -1 is -8, so my a value is 1. I did a lot of that. So here's my final equation, the understood one. I'm going to put the x out front. then x plus 2 times x minus 3 times x minus 1 to the second power. Normally, you put your singular factors like x first, your squareds or cubes last. Just kind of done in an increasing order. And there's question 2. Question 3 is a whole bunch of function notation. It's on there. We're supposed to find f of 3. This is equivalent to f of 3 plus f of 3. So how do I find f of 3? Well, I plug a 3 into function f, which is up here. It's 3 times a 3 minus a 5, which is 4. All right. Now I'm supposed to do f of 3 plus f of 3, so I'm going to do 4 plus 4, which is 8. Not hard, is it? No, it's not. Here we're supposed to find g of f of negative 2. I'm going to work my way out. I'm going to find f of negative 2 first. 3 times a negative 2 minus a 5 is a negative 11. And now I'm going to find g of negative 11. And g is 5x plus 3. So 5 times a negative 11 add a 3 is negative 52 all day long. All right, now we're moving on to example C. C is f over g of negative 3. This is f of negative 3 divided by g of negative 3. So somewhere off to the side, I find f of negative 3, and g is 3 times negative 3 minus 5, which is negative 14. And I also figure out what g of negative 3 is. G is going to be 5 times a negative 3 plus a 3, which is negative 12. So f of negative 3 over g of negative 3 is negative 14 divided by negative 12, which obviously reduces to 7/6. Right there, final answer. Easy peasy Japanesey. Example D is f plus g of 2, which would be f of 2 plus g of 2. I'm getting tired of typing, but if I plug a 2 into f, I get a 1. If I plug a 2 into g, it looks like I get a 13. So 14. E is f times g of negative 2, which would be f of negative 2 times g of negative 2. F of negative 2 is going to be negative 6 minus 5, which is negative 11, times g of negative 2, which looks like negative 7 to me, because 5 times a negative 2 is negative 10, add 3 there, and it would be 77. Ah, look at this one. G of 3 divided by f of 3/5. All right, well, g of 3 is easy. 5 times 3 is 15, plus 3 is 18. Now let's find f of 3/5. It is going to be 3 times 3/5 minus a 5, which is 3 times 3 is 9/5 minus 5, which would be 25/5. So it turns out to be, what, negative 16/5? All right, so now I can do 18 divided by a negative 16/5. You'll see all the push buttons in a calculator and just, be amazed how brilliant you are. That's going to be 18 times negative 5/16, which is negative 90/16. Divided by, what, 2, and we're at 45/8. That won't reduce anymore. It seems right. All right, moving forward. I still got about 10 minutes before classes start. Given f of x is 4 times x to the negative first and g of x is 3x plus 7, find some stuff. Now, the first thing I'm going to do is consider what f of x actually is. I wrote it as 4x to the negative 1 on the test, which, if we understand rules of exponents, is 4 over x. So find f of g of x. And I should probably write this one out. It's hard for me to type these fractions. So they want me to find f of g of x. So I'm going to take this stuff right here, and I'm going to put it into that x right there. It's going to be 4 over 3x plus 7. And this is why I don't write anymore. I'm struggling to write on this thing. That's supposed to be a 3. Now, it says state domain. You have a rule here, 1 over a. A cannot be 0. So 3x plus 7 is not 0. X cannot be negative 7/3. There we go. Part B is G composed of f of x. This one I can type. It's not as hard to set up. So f of x happens to be 4 over x. And I'm going to replace that x right there in G with that. 3 times 4 over x. And I'm going to add 7. Now, I can't divide by anything, by 0, so x cannot be 0. It's got the easiest domain of all of them. There's my domain. And then I'm just going to clean up 3 times 4 over x. It's going to be 12 over x. Add 7. That's all there is to that one. Example C is f of x over g of x. So we're going to take, and this one I have to write out because it has to be cleaned up quite a bit. It's going to be 4 over x divided by 3x plus 7. Now, that's going to clean up just a little bit. If you're going to divide by something, by one thing, you just throw that one thing in the denominator. I'm sorry about this. I'm trying to write this as nice as I can, but my laptop is too old to record and apparently write at the same time. Right here I can tell you that x can't be 0, nor can it be the negative 7/3 we had earlier. I hope that makes some sense. I hadn't been doing this on the last couple of examples because I'm trying to save a little time. All values of x such that x is not 0, and that is a 0, believe it or not, or negative 7/3. Now I'm going to clean up my composite function a little bit. I'm going to use the distributive property. X times 3x is 3x squared. And then x times 7 is plus 7x. All right, that was simple enough. D is going to be g of x divided by f of x. So that's 3x plus 7. So annoying. I already have horrible handwriting, and I don't need this thing making it any worse. I'm dividing it by f of x, which is 4 over x. So I'm going to have to use the whole multiply by the reciprocal rule on this one. And by the way, x can't be 0. Because if that was 0 right there, poof, world's over. It should be all it can't be. Anyways, I'm going to flip the bottom. Because that's how you divide by a fraction. You multiply by a set reciprocal. Then I'm going to use the distributive property. And I'm going to get 3x squared plus 7x. Maybe. Both pieces over 4. And that's where I'm going to stop for this morning.